Talking about why some people get PPS and why other people who had paralytic polio apparently do not, which is a really interesting question, and there is no known reason for this yet. I can only hypothesize, but based on evidence and scientific articles published in peer-reviewed journals, Eddie Bolenbach and I together have kind of developed a hypothesis. So it's probably easiest to explain if you take three people, arbitrarily three people, who get acute polio. So we're talking now back in the time when the polio virus was circulating. So one person gets polio, and the polio virus is what's called a lytic virus, which means that when it infects the cell, it multiplies within that cell until the cell bursts and dies and bursts, or bursts and dies. I guess it actually bursts first and then it dies. But in other words, it kills the cell by causing it to explode, get rid of all the virus. Then the virus leaves that cell, moves on to the adjoining cells, infects those. They produce more virus till they blow up with too much virus inside of them and they die, and then so on and so forth. And so you get this continuing invasion of virus cell to cell to cell. And this is what produces paralysis, because as the cells died, of course, all those are the cell bodies in the anterior horn of the spine. So all the processes which lead to the muscles in whatever area of the body, they innervate, they die, there's no longer any messages being sent to the muscles, and paralysis results. Now, there's a really interesting thing that happens, because the poliovirus is an enterovirus, and enteroviruses are famous for their ability to mutate, and this is what they do best. They mutate in order to survive in a new environment. Now, the poliovirus mutated in each cell that it infected. In most cases, the mutations did nothing unusual. Sometimes they made something called a defective interfering particle, which is a virus that actually could not be infective. Other times, though, one or two of the viruses would mutate such that instead of causing the cell to burst, they could remain viable in the cell, which means that when that virus infected the next cell, rather than producing more of itself until the cell blew up and died, maybe only a few copies were produced of the virus, and they stayed inside that cell, and that cell lived. Now, we don't really know how the virus looks in those cells. It might be a fragment of the virus, because that's been seen, or it could even be the whole virus that's still intact. But most likely it's just a portion of the virus that remains. Okay, so now let's go back to these three people that got polio. So the first person got polio. The virus infected the cells. Some of them burst. A few of them died. But the immune system kicked in before there was enough death to cause paralysis. So this person may have had some muscle weakness, or maybe didn't even notice that, and that would be the case of non-paralytic polio, where they actually had spinal cord involvement, but it was not, the virus did not replicate sufficiently to cause paralysis. But it did replicate enough to mutate and to go into an adjoining cell, infect that cell, and that cell survived, carrying with it the little bit of the poliovirus. So there's a person who had non-paralytic polio, grew up, survived, never had any real indication that they'd had polio, but are carrying these little fragments of the virus. In the second person, the virus infects the cells, some of the cells die, enough cells die to produce paralysis before the immune system kicks in. Excuse me. So that person also had the virus mutate to the point that some of the cells, adjoining the ones that did die, contained little bits of the virus, enough small fragments of the virus, but they don't impair the function of the cell. The cell can still function as a normal neuron. But that person would have had significant paralysis in some area of the body. So they grow up. And the third person also had the same sort of situation where they got infected with the poliovirus. Poliovirus killed enough cells so that they wound up with paralysis. And the mutation that occurred in the poliovirus was not of the type that allowed that virus to remain in a living cell.
mutation is a funny thing. There's no predicting how the mutation is going to occur. That some mutations are more likely than others, just because of the structure of the viral genome, but you can't really predict. So in this case, the person had paralytic polio, but there's no cells remaining in that person's body that have little fragments of the polio virus. Okay, so what happens 30 years later? So 30 years later, we revisit the same 3 people. Each one, of course, stands for a whole group of people. They're not just one person. So we revisit the same 3. And we find that people who had non-paralytic polio are coming down with new muscle weakness and fatigue out of proportion to effort expended. And they have no idea why. Or they may have been diagnosed with polio, but it's so long ago in their history that they really don't understand what's happening. In the second case, we have people who had paralytic polio who are now developing new muscle weakness in areas often that they hadn't realized were affected in the first place, developing severe fatigue, new pain, all of these things, and they, at least now, are fortunate enough to understand that there is a label given to this called post-polio syndrome, and there are now lots of groups where people can get more information about this. So these people in one way are the most lucky because they actually have a diagnosis of polio. Post-polio PPS syndrome has been publicized now to the point that people understand that it's there. So these people can go to PPS groups for more information. And the third person, the third group, they had polio, but they don't have PPS. What's the difference? Why do some people who had acute polio, had paralytic polio, 30 years later really are no worse off or no better off than they were at the height of their best recovery after they recovered from acute polio? What's the difference? The hypothesis is that the difference is the presence or absence of those little viral fragments remaining within the cells of people who had polio. Now, the first thing to know is that those cells are not infective, those virus bits are not infective. Nobody is going to pass polio to anybody else. You cannot even pass polio to should you be a woman who has a child or becomes pregnant with a child, you cannot pass those polio fragments to even a fetus that you're carrying. They are in no way infective. But, okay, so what do? Well, I mean, they're sitting there, they're going to do something. Everything that's sitting in your body does something. Well, the best guess is that these little fragments are capable of causing subacute chronic inflammation. That is, that the little bits of the virus occasionally get out of the cells. How? Okay, well, there's numerous mechanisms where they could get out, but let's just leave that in the area of mystery for the time being. We could go into that, but that's, of course, in virology and cell biology. They can, in fact, though, leave the cell and be seen by the patrolling immune system, because your body constantly has an immune system on patrol. There are cells, macrophages and other cells, whose sole function is to march around your body looking for inflammation that shouldn't be there, or causes of inflammation, foreign particles, foreign bodies, viruses, bacteria, molds, fungi, things like this, things that shouldn't be in your body. So their sole job is to spot them and set up the alarm.